Before we start doing some law of index MC question, if you are not very strong in foundation, I suggest you to watch this video first about the explanation of why we have those index law. If not, if you feel comfortable or confidence, then you may just skip this part and handle the questions by yourself. So first, before that, it start from a plus a plus a. Long time ago, we think that repeating adding something is so trouble. That's why we invent a method. We call this a times 3 times, or we just write 3a instead. But however, if we have some situation like a times a, we also think it's trouble. But we already use this method, so we need to use another method to notate it, to present this idea. That means index notation. And we write a and a small 3 at the upper right corner. To represent, we repeat it to multiply 3. So this is the basic definition of our index notation here. And all this are based on this definition, and then we devise some method to simplify it. So it's totally fine for us to understand one by one. Start from the first one. A power of m times a power of n is equal to a power of m plus n. Many of you know that, but may not everyone remember the reason why it is like this. So in maths, if you want to be a elite student, you want to able to understand most of the topic, try your best to understand it. It's difficult to understand is because m and n are some unknown, so we use some example. Let's say a power of 3 times a power of 2. Because we don't know about the index law here, we just try to use the very traditional method to present this idea. A power of 3, based on the definition, that means a times a times a. Similarly, a power of 2, that means times a times a. So when we count how many a here, then we count, okay, 3 originally, and then we have 2 more. So that's why, based on our definition of index law, this is power of 5. We repeat multiplying a for 5 times. So that's why this is a power of 3 plus 2. It's because we have 3 at left hand side and then we add 2 more on it. So that's why it is this one. After that, we already proved the first one. We are now going to prove the second one, which is quite similar. Again, we don't use m and n. We use a power of 5 over a power of 2 maybe. So if we use this logic similarly, about the fraction line, this is a power of 1, 2, 3, 4, 5. And what below the fraction line is a power of 2. And then based on what we learn about fraction, we find the common factor about the fraction line and below the fraction line. We can both sides divided by a. We still find common factor, we both sides divide by a. After that, we don't find anything left below the fraction line, so that means 1 times is left. So if we simplify it, that means a power of 5, we take out 2 over 1. That means a power of 5 minus 2. That's why it is minus. It's because they are similar, then we have to cancel them out. So we remove 2 from 5.